Hey everyone, this is Devanshi Kesarwani and welcome to my channel, and we will solve the problem digit queries from Cses problem set. And this problem is more of mathematical than of coding, so let's get started. Okay, so we will be given with an infinite string that consists of all positive integers in increasing order. That means this is an infinite string that consists all positive integers in increasing order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and so on. So this is an infinite string. Then we need to find what is the digit at position k in the string. So this k would be given and we need to find what is the digit present at that position. So for example, let's say k is 7. So what is the digit present at position 7 in the string? So I would say 1, 2, 3, 4. I am writing this position. So this is the 7th position and the number present is 7. So I would display 7 as my answer. Now let's say what is the digit at position 12 in the string? So I will again write the position in front of these numbers. So this is 1, 2, 3, 4, 5, 6, 7. This would be 8, 9 and this would be 10. This would be 11, right? I'm just writing the position of these digits. Then this would be 12. So my answer would be 1, right? Because the digit which is present at position 12 is 1. Great. Let's go for another 23. So I would keep on writing this. So this would be 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 and this would be 23. So my answer would be 6, right? So I hope you get the question now. So let's see how we can build this. Okay, so this is an infinite string, and to get started, if someone asked me what is the digit at position 7, I would happily give without thinking the 7 would be, right? If someone asked me 5, I would happily say that would be 5. If we are asked for 9, then I would simply say this 9. But if now someone asks for 12, what is the digit at position 12, then the problem comes. The problem lies that now these are 2-digit numbers. Each would have its own position. This would be 10, this would be 11 and this would be 12. So it strikes that you are asking me to find the digit at position 12. So to find that digit at position 12, I need to first figure out that it comes not under 1-digit number. It comes under 2-digit number. I need to first figure out that which interval it lies. It lies, right? We need to first figure out this. That okay, you are asking for 12, then this digit would surely come under the second 2-digit numbers, not in the 1-digit number. That means the problem reduces to such that we need to first find the intervals. First we should get the intervals. We need to find the intervals that the given position lies in this interval. Then we can proceed. Okay, so how many number of digits are there in 1-digit number? 1-digit number start from 1 and goes up to 9. So number of digits is 9. Correct? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have total number of digits as 9. Okay. How many number of digits are there in 2-digit number? So 2-digit numbers start from 10 and goes up to 99. So let's see how many number of digits are there in 2-digit number. If I look at this first starting 2-digit number 10 and goes up to 19, then there are 2 digits, right? 1 and 2. So I would say there are 2 digit and how many such numbers are there? 10, 11, 12, 13, 14, 15, 16, 17 and 18 and 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 such numbers, right? If I am just looking from 10 to 19, I don't care about the rest of the 2-digit numbers. I am just caring about this 2-digit number starting from 10 and going up to 19. So there are 2 digits and there are such 10 numbers, correct? So I have written 2 into 10. But 2-digit numbers are from 10 to 99. That means number of digits would be, first the block would of 10, then 20, then 30, 40, 50, 60 and so on. That means we have how many such blocks? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 such blocks. Then that means I need to multiply 9 also, correct? Because there are 9 such blocks and each block has 2 numbers and it has 10 numbers in it. So 2 into 10 and there are such 9 blocks. That means 2 into 10 into 9. So we got 180. So I can say there are 180 digits in 2-digit number. There are total number of digits available in 2-digit number is 180. That means if you start from counting 1, 2, 3, 4, 5, 6, 7, 8 and goes up to 99, you will reach 180 digits, number of digits. Then I would ask total number of digits from 1 to 99. That would be 1-digit number plus 2-digit number, correct? Total number of digits I am asking. Total number of digits from 1 to 99. That would be 1-digit number plus 2-digit number. So 1-digit number is 9. 2-digit numbers, there how many 2-digit numbers? 180. So if I add them, then we would have 189. So this tells that total number of digits from 1 to 99 is 189. Let's look clearly what this 189 number is saying. This 189. Let's try to find it signify. What it does is signifies. So we have, I'm saying total number of digits from 1 to 99 is 180. 189. I am saying this. Total number of digits from 1 to 99 is this. That means total digit from 1 to 99 is 189. That means this 9 would be 189, this would be 188, this would be 187 and this would be 186. Let me again clearly explain you. So I am saying that starting from 1 to 1, 2, 3, 4 up to 9, we have 9 digits, correct? Then starting from 10, 11, 12, 13 up to 99, these are 2-digit numbers and we have calculated earlier that these are 180 digits in total. 180 digits. That means this would take this if I position that at 1, then this would be 2, then this would be 3, this would be 4, 5 and this would be 180, correct? If I start counting here, then this would be 180. That's what I am saying. There are 180 digits. How they are 180 digits? If you count 1, 2, 3, 4, 5, 6, 7, 8, then this would be 180. Then this would be 179. Correct? Here would be 98. This would be 178. But wait a second, I am saying total number of digits from 1 to 99. So these 9 digits should also be added. If you add this, then there would be a shift of 9. So this would be 189, because you have added 9, right? 9 more digits. So this position would shift from by a 9 gap. So this would be 189th. I hope I am clear. There are 180 digits, and if you count 1 2 3 4 5 6, then this would be 180. And since you are asking from 1, starting from 1, so there are 9 digits already present earlier, so you would add, so this would shift from 9, so that would be 189. So what does this signifies this? If you have free time, then you can start numbering like 1 2 3 4 5 9, then this would be 10 11 12 13. You would read this would be as 189. Great, let's move ahead, and now this time let's try to analyze 3-digit numbers. So we know 3-digit numbers start from 100 and goes up to 999. Then I can say this is 100 to 199, then this is a block of 1, right? One block. I would have a block of 2 also, then block of 3, block of 4, block of 5, block of 6, block of 7, block of 8. If you try to analyze, first let's try to analyze the block of 1. So how many number of digits are there? You can pause and can calculate by your own. It is simple. There are 3, so you would multiply 3. And how many such numbers are there? If you count 100, 101, 102 and so on up to 109, you would get 10. So there are 3 into 10 digits present in this only. Then how many such blocks you have? You have a block of 2 3, so you would have 1 2 3 4 5 6, would have 9 such blocks. So and also this is 3 into 10, this is this, right? And you would have this in block of 1 only, 100 to 109, then 110 to 119, 120 to 129. So these are 10 blocks in block of 1 only. 1 2 3 4 5 6 7 8 9, so and 10. So you have 10 such blocks. So you would multiply that 10, and then how many such blocks are there? This is the number of digits present in this block of 1 only, right? 3 into 10, and you have 10 such blocks. So 3 into 10 into 10, and then you would also have similarly for 200, 3 and 3 4 5 6. So you would multiply it by 9, right? 1 2 3 4 5 6 7 8 9. So I have this 9. That means you have this amount of 3-digit number available with you. Cool. Let's see for one more 4-digit number, and this time we would clearly see what's happening here. So you can pause this video and try to work on your own 4-digit number. Okay, so I hope you have done it. So these are 4-digit numbers, 1000 to 4 nines. Then let's try to analyze. This is 1000, 1009. Then you would have again a block of 1 going like this. That means 1010 to 1019, right? Then 1020 like this. So you will go up to 9, and you have 4. And how many blocks you have? 10. If you analyze this only, this part I am analyzing, so you would have and yeah, let's see 4. So this is 1. Then you would have another block of 1 also, which would be 1099. Then this would be 1100, 1109, and so on. Then you will have block of 2, 3, 4, 5, 6, 7, 8, and 9. That means if yeah, okay. So I am trying to analyze this one. So there are 4 digits, and you have how many? You have 10 such numbers, right? 1000, 1000, 1002, so on. So that's what it is written. Then I see in this block of 1 you have this 10 such numbers. Yeah, this 10 such numbers. So we multiply this 10. Then you again have in this block of 1 again 10 such numbers. So I would multiply again 10, and this is goes for all the blocks. So block of 2, so this was all block of 1. Then you have 2, 3, 4, 5, 6, 7, 8, 9. So you would multiply 9 also, correct? So you would get this. So these are 4-digit numbers. Total number of digits, total number of 4-digit number is this. Okay, so let's try to analyze. 1 digit we got this. This is just 1 digit. For 2 digit we got this, and this is, if you remember, this would be 180, right? 9 to the 18, and this would be into 10, that would be 180. So I'm not counting from 1 to 2. I'm just saying 2-digit number. How many 2-digit number are there? 2-digit number are given by this formula. Then 3-digit number, we have this. 4-digit number, the formula is in front of you. 9 into 4 into 10 to the power 3. So I can generalize this. I can say this. If you have n-digit number and you want to find the total number of digit in n-digit number, total number of digit, I should write it. Total number of digits present in n-digit. In this case, let's take the example of 4. So total number of digits present in 4-digit number is 9 into 4 into 10 to the power 4 minus 1, and this would give you the same result. So I have generalized this. Then I can also do the sum, which would be, suppose I want to ask total number of digit from 1 to 99. Then you would say, okay, I know this formula, so I would apply it for 1 digit. Then I would add it for 2 digit. Then I would have total number of digit from 1 to 99, that would be 189, correct? You applied for 1, you applied for 2, because I was asking from 1 to 99. That means I can write this formula. This formula is saying total number of digit, total number of n digits number. So if you want to find the total number of digits, total number of 3-digit numbers starting from 1. So I would say that you need to say, let's say you need to find the total number of digits from 1 to 999. Then you would simply put this in formula. This would be x is 1 into 10 to the power 0 plus x would be 2 this time, and n is 3, right? Because we need to find total number of digit from 1 to 3 digits. N is 3. So this time x would be 2, right? So 2 into 10 to the power 1 plus x would this time be 3, and this would be 10 to the power 3 minus 1, this would be 2. So 10 to the power 0 is 1 only, 20, 300. And if you add this, you would have 3, 2, 1. And if you multiply 9, I am writing here, so 9. So you have total number of digits starting from 1 to 999 is this. And you know what does it signifies? It signifies that 999, this would be 2889, this would be 2888, this would be 2887, correct? Great. So let's do a problem here, and we will see if we are able to understand this problem, then we can easily write the code. In just the code is just very simple. So let's try to solve this question. So this question says find the 2871 digit in the infinite sequence of increasing integers. So you remember this formula? Okay. Now if n is 1, and if you put this into this formula, you would get 9. If you put 2, you would get this 189. If you get 3, then you would get this formula. This I just proved in the in this before slide. This I proved. So, and if you put 4, you will get this. So now you find you want to find the 2871th digit. You remember what does this in the beginning we were talking about that we need to find the interval. In which interval this comes? 2871. We need to figure out this. And if you look at this chart, which is in front of you, the table, then you can say that okay, so this is 2871 is less than 2889, and it is clearly definitely greater than 2-digit number, because 2-digit number ends at 189, then 3-digit number start from here, and it goes up to 2889, and 2871 is less than this. Then I can clearly say that okay, the number of digits, this is 3-digit number, n is 3, correct? Because this is less than 2889. And what does this 2889 is? If I write this in backward, then so that means this would be 2889, this would be 2888, this would be 2887, this would be 2886, this would be 2885, this would be 2884, this would be 2883, 2882, 2881, 2880, 2879, 2878, 2875, 74, 2873, 2872, this would be 2871, this would be 2870, this would be 2869. And we are interested to find 2871th digit, and this is 2871th digit. Okay, so we have found that this is n equal to 3-digit number, and this is 999, which is ending at 2889. We need to find 2871th. Okay, so how far it is from 2889? We know this. So we need to find 2871 digit. How many digits it is away? So if you subtract simply 2889 minus 287, you would get 18, and this is 18 digit away. if any issue, you can always count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So this is 18 digit away. Also, we know that this is 18 digit away, but each such number is formed by 3 digits. Each such number is formed by 3 digits because this is a 3 digit number. This is a 3 digit number. That means I can simply divide 18 by 3. Why I am dividing? Because we know this is 18 digit away and each number is made by 3 digits. So that means this is 6 numbers away. This is 6 numbers away. You can count. So this is 1, 2, 3, 4, 5, 6. So this is 6 number away. And also, if you subtract 999 minus 6, because this is 6 numbers away, you get 993. And this is our 993, but we need to find in this 2871 digit. Also, when you have divided here, you found that it is completely dividing. It is completely dividing. There is no remainder left. Remainder is 0. That means we are arriving at this only because this is completely divisible. If there was some remainder, let's say 1, then that means you have reached here, but there is a remainder left. That means we are talking about this digit. Try to understand, try to take a feel of this, that this is 6 numbers away you have calculated and you have completely destroying that number with there is no remainder left. That means you are arriving it here. If the remainder is 1, then that means this is this. If the remainder is 2, then this means this is the number. We'll see one more example to clarify that when we are getting a remainder. Until now, you can take away is that you are completely destroying this. That means you are just arriving at this last position, and I have counted this for you. So this was our thing. We calculated first that which interval it belongs, and we found that it belongs to 3 digits interval by having that sum formula. Then I know that 999 is 2889. So how much far is this? 2871. So I just simply subtracted. We get this is this much far. Then we divided because we know that it is made up of this numbers are made from 3 digits. So we get this 6. That means this is 6 numbers away. And if we subtract it, we get this 993. And also we found that it is completely dividing. It is completely dividing. That means we are arriving at the end. Let's take another example. And this time you can pause the video and try to work on this own. Simple. First find the which interval it belongs. Then calculate the distance, how much far it is. Then since you know it which interval belongs, so that interval represent that these numbers are from those end digit number. You divide and you will get how many numbers you are away. Let's start doing. So this is 2869. Again we have the sum formula. Then we check that for it the last ending is 3, 2889, and this is 2869. So it is clearly less than 2889. That means this is yes, and is 3 digit numbers and sum is 2889. Sum is 2889 again. Then I simply subtracted. That means I know that this is 2889 and how much far it is? It is 20 digits far, 20 digits away. You can again do like this how I did. So this was, I think if you remember, this was 2871. This would be 2870. This would be 2870. This would be 2869. So if you count, this is 20 digits away, and I also know that these are formed from 3 digits. This is 3-digit interval, so that means this is 6 numbers away. But and the remainder is 2, because if you divide 320, you will have, it will go by 6 and the remainder would be 2. What does this remainder says? It says that, okay, so I have completely divided till here. Now you are two digits away to completely divide yourself. So that this two digit means you have arrived here, and the remainder says you are 2 digits away. That means this is, if this is 0, remainder 0, then this is 1, then this is 2. So if you see the question part, it gives 6. That means it says that you are 6 numbers away. So you simply subtract it, and then since remainder is 2, so you would say that the answer is this 9 is the answer. Okay, let's try to just summarize the steps what we were doing. We first worked out to find the sum. 2889 comes before 3-digit interval, so that means this is present in 3-digit interval. We have the formula, we can directly apply this to our code. So remember this formula, write it down somewhere. This is the formula which we will just replicate in our program. Then what we did, we calculated the digits and number away. This is the step 2. In step 1 we found the sum. Then in step 2 we found the digits and number away. This is simple, we are just subtracting it and dividing it. Then in the third, you are tracking down the remainder. You have divided in these steps, in this second step, and then you are noting the remainder. That is easy, I think. Then you calculate the number. You have the question part, you subtract it, you get the number, and then you check the position by saying the remainder is 0. That means I am in this LSB, least significant, like here, and remainder 1, that means this, remainder 2, this, remainder 4 would be, if some big number, then this would be this, so on. So, and also one thing, since you have this sum, how you get this is important, right? Because this tells the offset. So when you said that this is a 3-digit number, so what is the ending point of the 3-digit number? Like, what is the ending and 4-digit starts? So that is 10 to the power n minus 1, right? If you put 3, so 10 to the power 3 is 1000, and if you subtract 1, you get 999. So that is our 3-digit ends here. So since you are subtracting here, so you would need this. So I would say 10 to the power n minus 1 minus away, which you calculated in this second step. Great, right? So we have these steps. We are gonna do the same replication when we go to the programming section. So let's try to now code this out. Okay, so let's write the program of this digit queries. And if you look at the constraint, then we are going to use, of course, long because int is not going to store, and therefore let's go for long. Okay, so first thing it is, they want to have the number of queries, and then we need to accept the key, the position. Okay, so let's have first queries on the position and we'll accept the queries and then we'll write our code here. So we need to get the position which we need to calculate for that digit. So we have the position, and then what else we need? We need this n, right? N and sum. These two variables are also needed. So let's make them lln. And what could be the least value of this number of digits? That would be 1, right? And also we need sum to calculate the sum. We have this. Now we need to first calculate the sum. So we have this formula 9 into x, which goes from 1 to n, and then this 10x minus 1, 10 to the power x minus 1. So I would say sum, since we need to add this, accumulation is also there, so we need to accumulate, that's why we'll use this. And then 9 into n into 10 to the power x minus 1, and this n is starting from 1 and it will increase. But we are not going to use the inbuilt power function. That is so because it is not suitable for large integers, and surely we are going to hit large integers in this question. Therefore, we are not going to use this inbuilt power. Instead, we are going to make our own power function which accept the base and the power. So base in this case is, let's look at the base. Base is 10 and power is n minus 1. So I would say base is 10 and power is n minus 1. And in each iteration you need to increase the n. We'll write the power function in just a bit. So you need to do this. But how long we need to do this? We need to do this until we are below the sum, right? We are below the sum, which is 2889 and 2869. So as soon as this sum exceed this 2869, we are gonna stop. We will write the running condition. That means the condition would go like this, that we need to keep on going until this k is bigger than sum. In the first case, k is, let's take the example of 2869. This is the k. So you keep on calculating the sum until this 2869 is bigger. So in first case, 2869 would be definitely bigger than 1, right? When the sum would be 9. When the sum would be 9. Then you will hit 189. Then this is definitely going to bigger. And then you will hit 2889. Oh, the condition is stopped. That means this is our n, which we need to wrap. So let's add this in while loop. Keep on going this, and let's use do while. Doesn't matter which loop you prefer, but since I have written like this, so let's go for do while. And also let's try to just iterate it once. So in the first case sum is 0, and let's take the k as 2869. So in the first case sum is 0, 9, and n is 1, and power 10, and n is 1, so 0, this would give us 9, and n would become 2 here, and our 2869 is greater than equal to 9. Yes, it is greater than equal. Okay, keep running the loop. So now our sum is 9, right? Sum is 9. So 9 plus 9 into 2 into 10 to the power 2 minus 1. So this would be 189, right? Sum is 189, and n would become 3. N is becoming 3, and this would be 189. Okay, so now this condition satisfied, it is true, so we'll move, the loop will continue running. So in this case, in the sum would be now 189 plus 9 into n is 3, and this would be 10 to the power 3 minus 1, which would be 2. So if you do this, so 9 3 is 27, 2700, so this would be 2889, and n would increase, right? So n would become 4, and our this would be 2889. Is 2869 greater than 2889? No, it is smaller. So break, stop. The loop is going to stop running, and we will have the n value. Now if you see the n value, it is 4, but this value correspond to n equal to 3, right? We have seen earlier, this value correspond to n equal to 3. That means we need to decrease the n by 1. We need to decrease the n by 1. So we'll write now n minus minus. So that is going to set the n. Now let's write this power function above here. So ll power, and it should accept the base and the time. How many times you want to run this? So it is going to return the power. So this is, I'm just writing a simple power function. So I will say while times minus minus answer equal answer into base, and finally we will return answer. What I have done, let's take an example and try to understand here. So if you look, let's say base is always 10, and let's take the times as n is 3. Okay, so answer would be 1, this would be 3 minus minus, that means this would become 2, and answer would be 1. This 10 to the power 3 basically means that we need to multiply 10 3 times, right? So this would answer would be, in first case answer is 1. So 1 into base is 10, so 10. So answer would be 10. Then this would become 2. So this would be into 10, right? then this would become 1, then this would be into 10, and then this would become 0. The loop is going to stop and you are going to return this answer, which is 1000, right? So that is a simple power function. And now let's see what's the next step. So next step is we need to calculate the digit and number away, and we know we can calculate by just subtracting the sum to the given k and then dividing the order which we have found. Okay, so I am calculating now. Digits away. So let's store it in away, and that would be sum. Let's look again, sum minus k, right? Sum minus k, and you divide this by n. So basically I have combined these two and written a single line. Also you need remainder also. So I would copy this. I will say ll remainder is, and how you calculate remember, by using this percentage. Now we need to calculate remainder, which we have done, and now we need to calculate the number away. So how we do? 10 to the power n minus 1 minus away. So I would say basically we are calculating now number. So I will say ll number to be, let's put this, wrap this in a power 10 to the power n, that means 10 to the power n, and subtract minus 1 and minus away, right? I have just written this down, 10 to the power n minus 1 minus away. Now that means we have the number with us. We have the number with us. So we have this number 993, and but also we need to use this remainder, right? Because if this remainder is 0, this is our answer. If the remainder is 1, this is our answer, and this is the remainder is 2, then this is our answer. If you cleverly look this, then this number is in integer. If you convert this into a string, then you get a clever property of the string which comes with indexes, right? 993. It comes with indexes 0, 1, 2. It is just written reverse, so we can handle it. Therefore, this would be a clever way to convert this number into a string. So I will say string result is equal to, we can use the inbuilt function to a string, and this is going to convert my number to a string. And now I will use the clever property, which is, now result is a string, and we can use this overload operator, square braces, and I would say result dot length minus 1 minus remainder would be our answer. How this is our answer? This is wrong. So how this is the answer? Let's try to look this. So let's say my number is 993 and the remainder is 2. Therefore, now this is in our string format, this string result. So we have this indexes which I am writing here, 993, 0, 1, 2. Now I am saying result.length. So length would give us 3. And we know the indexes start from 0. That means I have done 3 minus 1, that means 2. That means I am standing here. And then I am saying 2 minus remainder. So 2 minus remainder is 2. So we arrive here. So this is a clever way of writing it. So this is our answer, right? So that's how we wrote, and also we can display this here only. And since there are multiple queries, we can leave a line. Nice. Let's try to submit this and see if this is working. Go to submit, visit queries and open and submit. And we get wrong answer because I think nowhere in our code we have accepted the queries, right? Nowhere we have accepted the queries. So let's do this. And okay, let's give it one more round. Visit queries and submit. Hope this time it works, and it works. Cool. So this was the complete explanation. Go slow, and this is a very interesting mathematical problem, I would say. And I will meet you next time. Bye.